Hi everyone, Quiveen here from the comfort of my kitchen. In today's video, we are going to take a quick look at the bigger planets in our solar system, but mostly Uranus and Neptune and how they differ from Jupiter and Saturn. So in the next couple of months, I will make a video focusing on the ice giants, Uranus and Neptune individually, and talking a little bit about their collections of moons. But in this video, I want to talk about both of them and compare them to the gas giants that we're a little bit more familiar with. And there's a great opportunity and reason to talk about them at the moment. Looking here later in June, we can see both of the gas giants, the two biggest planets in our solar system, Jupiter the biggest and Saturn the second biggest, both in the sky together along with Mars early in the morning at sunrise. We can see the moon here as well. This is right at the end of the month, a little bit earlier in the month. Jupiter's harder to see. We can still see it. The moon is not in the same place, not in the same part of the sky. I think they look pretty nice together like this. If you are closer to the equator, you'll be able to see Jupiter a little bit earlier in the month, but this should be visible to pretty much everyone. If we can see it as far north as Ireland by with this much of a margin, then there's a good chance you'll see it much further north than us as well. So we can see the gas giants here, Jupiter and Saturn. Unfortunately, the ice giants, they're not really visible to the naked eye. We're looking at the morning sky here in the city. We'll hop out to the countryside and we can definitely see the planets a little bit easier. They look much brighter, much clearer. We can see the Pleiades there above Jupiter, which is a nice thing to spot as well. But we're still not quite seeing the ice giants. I'll need to remove the atmosphere for Uranus, at least, to come up. There it is. Looking at the sky like this, even stars that are very faint, these ones over here, these ones over here, stars that we wouldn't see with the atmosphere turned on, Uranus is a pretty faint dot. Technically, it is of a magnitude, magnitude 5. Technically, it is of a magnitude to be seen with the naked eye, but it really is on the edge of possibility. Luckily, the fact that it's on the edge of being visible to your eye means you don't need much magnification to bring it into view. Even a little bit of magnification will make it technically visible, but due to the distances involved, despite the fact that Uranus is quite big, it's still going to look really, really small because it's far away, unless you're using quite a significant amount of magnification. So we can see even, around the kind of magnification that makes the Pleiades a lot more visible and brings many more of them into view, more than just 7 in the Seven Sisters. Uranus is still pretty tricky, and we really have to look in quite close before we start really seeing that it's a planet. There we can see some of the moons, and now we're starting to see that it is in fact a planet and not just a star. By observing Uranus over longer periods of time, it can be seen that Uranus is moving around the sky. Well, like the other planets, it's not staying in a relatively fixed position like the stars. But if we take a look over here, the sidereal period, those would be the so how long it takes to orbit the sun is 84 Earth years, a little bit more. It's got a very long year, so it takes a long time to notice that it's moving differently to the background of the stars. We can see some names here. You might recognize a few of them. Juliet, Puck, characters from Shakespeare's stories. There is another one in here somewhere that comes from a poem by another British writer, a British poet. So Uranus's moons are named just a little bit differently, getting their names from a different area. It's just about visible. If you have a telescope, then you should absolutely be able to see it. With the naked eye, I wouldn't rely on it. Definitely not at the moment. It's way too close to the sunrise to be seen with the naked eye at the moment. If we zoom in here, we should start to get Neptune highlighted. Neptune definitely isn't visible to the naked eye with the moon there. Yeah, the light of the moon was making it even harder to see. There's Neptune way out here. Neptune, it is further from the sun, so it takes even longer to get around. We can see over here 194, almost 195, or 165 Earth years before Neptune has orbited the sun once, so its years are much, much longer than ours. Taking a closer look here, it looks a little bit bluer, and we can see Triton, that large moon there, another big bright moon like Titan, but very different composition. We can see that Neptune there, very, very blue. Uranus, when we looked at it, looked more of a kind of a pale tealy color. It's hard to tell how accurate the colors we have are, especially in images. You really do need to look at it through a telescope, and of course with the distances involved and looking at stuff through our atmosphere, it's hard to really know for sure what it would look like if you were floating next to it in space. No actual biological eyes have ever gotten that close, that we know of at least. We have only sent probes past these planets, so their images, cameras do work a little bit different to the human eye. Sometimes color needs to be added back in through software, and then you're really estimating. It can be hard to pin down exactly what things should look like unless you have the exact wavelengths and you can replicate them. If we were to look at Jupiter and Saturn, and we can take a quick look here, we'll see that they are very different colors. And that's one of the differences that we see between the gas giants. There's Jupiter, nice kind of browny, beigey colors. It will be the same when we look at Saturn. These planets, Jupiter and Saturn, the gas giants, have a very different composition to the ice giants of Neptune and Uranus. We'll have a quick look at Saturn here just to see that color, that kind of beigey, browny kind of color. Saturn doesn't have quite as many storms going on as Jupiter. Neptune and Uranus do have storms going on. They have clouds moving through their atmosphere. Neptune has the dark blue spot, which is a big storm, which seems very, very similar to the storm that is orbiting, or that is going around on the atmosphere of Jupiter. There we go. There is the dark blue spot just over there. I'm not sure. Yes, it has the day here, 16 hours. Even though these planets take a long time to orbit the sun because they're so far away, most of them don't take too long to rotate. Most of them are spinning very, very quickly. If we take a look at the dark blue spot here, you can see it looks a little bit similar to the Great Red Spot. Of course, it's a different color, and the color is down to the composition. We say ice giants for Uranus and Neptune. Ices in this case doesn't really just mean frozen water. There's a lot of different elements that are liquid below or solid below a certain temperature. Things like methane and ammonia that are a little bit different to hydrogen and helium, where you need to get the temperatures incredibly low, minus 200 to get things like hydrogen and helium solid, whereas you're looking closer to minus 100 or even 0 degrees for water, somewhere in that range for freezing things like ammonia and methane. And that's a lot of what makes up Uranus and Neptune. Uranus and Neptune do have a fair chunk of hydrogen and helium, but Saturn and Jupiter are almost entirely hydrogen and helium, something like 90%. And there's so much hydrogen and helium under so much pressure that it's believed to turn metallic. It's believed to become metallic hydrogen deep inside the atmosphere. Whereas Uranus and Neptune, and I'm going to ping pong back to Neptune over here again, Uranus and Neptune, they have what is believed to be supercritical liquid. So thanks to the temperature really being quite high, because these planets have retained some of the heat from the original dust cloud that formed the planets, and radioactive decay from materials that they've picked up as well. Even things like radioactive forms of oxygen and other things that will slowly decay over time, even if it's not a bunch of uranium. Things decaying, even if they're, certain isotopes of lead, can still generate energy. And if you have loads and loads and loads, the heat adds up. Neptune is actually producing quite a lot of heat for the amount of sunlight that falls on it, but it's still pretty cold being so far from the sun. It has a lot of ammonia and water under a lot of pressure under this atmosphere, and the atmosphere contains a lot of ammonia and vaporized water vapor and things like that floating through the atmosphere as well. They only have about 20% hydrogen in their atmospheres overall, and there's not enough hydrogen under enough pressure at their core to turn metallic. So on the outside, they have this different color. In the atmosphere, they have this different composition. And then deep down, they most likely have a different composition as well. Now, of course, we don't really know for sure exactly what the core of the gas giants and ice giants is, we have some pretty good estimates by measuring their gravitational field and how their radiation emanates, how their magnetic field is disturbed and perturbed by sending probes through their upper atmospheres and through their magnetic fields and sensing variations in them. In the same way that the Earth's magnetic field has been mapped out, and in certain areas the magnetic field is stronger or weaker, in the same way that the Earth's gravity has been mapped out. Gravity varies a little depending on where you are. If you have a lot of very dense stuff underneath you, the local gravity can be a little bit higher. It's not really anything that would make a difference to us, but sensitive enough instruments can pick it up. And in the same vein, satellites orbiting around these distant giant planets have figured out a little about their interiors, but even without going that deep, just by looking at them, we can see by the color that the gas giants and the ice giants are quite different. And even just looking at the chemicals in their upper atmospheres, the bits that we can really see and be sure about, there is definite differences in the makeup between these different giant planets. And of course, Jupiter and Saturn, way bigger than Uranus and Neptune. The ice giants are way bigger than the Earth and Venus, but the gas giants are significantly bigger again. So that's just a little bit of a comparison between the two different groups of the 4 largest planets in our solar system. I will go into more depth specifically about Uranus and specifically about Neptune in the coming months. So if you'd like to catch those videos, make sure to subscribe to the YouTube channel. If you'd like to read a little bit of this information, I might have more numbers in the written information, then you can go to my website, queevinscontent.ie, and hopefully either way, you will come back for the next videos.